So for this lesson, we are going to be talking about dot products. So I want you to first recall that vector addition and subtraction are operations that result in a new vector. And the dot product is another vector operation. However, it results in what is a scalar. So if v equals a1, b1, and w equals a2, b2, then the dot product v times w is actually defined as, so we'd have v times w equals a sub 1 times a sub 2 plus b sub 1 times b sub 2. So the dot product of two vectors is also called the scalar product or the inner product. So you might see those wordings on a few questions. So for number 1 here, we're going to find the dot product of the given vectors. So for p times q, we are going to have 5 times 1, because those are our a's, plus negative 2 times negative 9. That is going to give us 5 plus 18, which is 23. Then on number 2, we have r times s. So this gives us 0 times negative 2 plus 4 times negative 4. So this gives us 0 minus 16, which is negative 16. And then for number 3, we have two linear combinations. So we are going to change those to component form really quick. So we'll have v as 7, 8, w is negative 1, negative 9. And then we will find that dot product of v times w, because we will have 7 times negative 1 plus 8 times negative 9. And that gives us negative 7 minus 72, and that gives us negative 79. And then for number 4, we also have these as a linear combination. So really quick, let's change it to component form. So we have 3, negative 7. And then d is negative 2, negative 2. So CD is 3 times negative 2 plus negative 7 times negative 2. So we have negative 6 plus 14, which CD equals 8. So now let's talk about orthogonal vectors. So orthogonal vectors are if two vectors are perpendicular, then their dot products are equal to 0. So vectors with a dot product of 0 are also described as orthogonal. So that's the word that we are actually going to be using rather than perpendicular. So we're going to find the dot product of each of these and see if they are orthogonal or not. So for number 5, we're going to see if m and n are orthogonal. So we're going to have 3 times negative 28 plus 7 times 12. 3 times negative 28 is negative 84. 7 times 12 is 84. So if we add those together, then we have 0 as our dot product. So yes, these are orthogonal vectors. And then for number 6, we have negative 3 times 40 plus negative 2 times negative 15. So this gives us a negative 120 plus 30. So it gives us negative 90. So this is no, these are not orthogonal vectors because that dot product is not 0. Then on number 7, we have linear combinations. So we're just going to change that really quick to component form. So we have negative 5 and -1. And then we have y equals -1 and -5. So we are going to have -5 times -1 plus -1 times -5. So this gives us 5 plus 5, which is 10. So no, these are not orthogonal vectors. So U is also linear combination. So we're going to change that to 12, -18. And then V is 9, 6. So we're going to have 9 times 12 plus -18 times 6. 9 times 12 is 108. And the -18 times 6 is a -108. So this is 0. So yes, these are orthogonal vectors. So some of our properties of dot products that can show up, just so you know, V times W is going to be equal to W times V, so you can change the order of that multiplication. If you wind up multiplying by a scalar, so use V as a scalar and have W plus X, it's going to work just like distribution usually does. So V times W plus V times X. And then if you have K times V times W, so you're multiplying 3 together, then that will equal KV times W. And it will also equal V times KW. It doesn't matter what order you multiply them. If you multiply a vector by 0, it will still be 0. And then V times V is going to equal the magnitude of V squared. So now we are going to find magnitude using a dot product. So we already have two formulas that already exist with magnitude. And of course, in the end, it doesn't matter how you get the magnitude. It's just that you get it. But if you want to find, another way, or you don't understand one way that we're doing it, then we can definitely find another way. So if V times V is the magnitude of V squared, then the magnitude of V is equal to the square root of V times V. So what we're going to actually be doing is finding the dot product and then taking the square root of it. So for the magnitude of R here, we are going to find the dot product. So it's going to be V times V, so 10 times 10 plus 24 times 24. So that is 100 plus 576, which is the square root of 676, which is 26. So that is a perfect square. So we are going to do the same thing with number 10 here. And so we have the magnitude of A equals the square root of negative square root of 7 times the negative square root of 7 plus negative 13 times negative 13. And that is going to give us 7 plus 169. And that will be the square root of 176, which is 4 square roots of 11. And then on 11, we have, see, a linear combination. So that is going to be as component form -2, 18. And so our magnitude of V is the square root of -2 times -2 plus 18 times 18. And so this gives us 4 plus, and then 18 times 18 is 324. That equals the square root of 328. And 328 simplifies to 2 square roots of 82. So then on number 12, it is a linear combination. So I'm just going to change that to component form really quick. And so that is going to be 14, -3. So the magnitude of K is going to be 14 times 14 plus -3 times -3. So that will give us 196 plus 9, which is the square root of 205. And that will not simplify, so that is where we are going to leave it. All right, so the last thing we need to talk about in this lesson, thankfully this one is a lot shorter than the others have been, but finding the angle between two vectors. So if theta is the angle between non-zero vectors v and w, then the cosine of theta will equal v times w over the magnitude of v times the magnitude of w. So if the angle between the vectors is 90 degrees, then the vectors are perpendicular. And if the angle between the vectors is between 0 and 180, then the vectors are parallel. So we're going to find the angle between each vector pair now. So we need to find the magnitude of each. So for u, that is 8 squared plus -7 squared, which is the square root of 113. And then for v, that is the square root of -7 squared plus -3 squared. And that is going to give you the square root of 58. So now we're going to go ahead and actually we're going to find the dot product between u and v. Now there's times that you can put this all together, but the first time out I don't really suggest it. I'll show you kind of what that looks like when we get started on the next one. So our dot product of u times v, that's going to be 8 times -7 plus -7 times -3. And so that dot product is actually going to be -35. So now we're going to put this all together with our cosine. So cosine theta equals -35 over the square root of 113 times the square root of 58. So cosine theta is going to equal negative 35 over the square root of 6,554. Now, I would honestly just go to theta equals the arc cosine and put this in my calculator. Because these are going to be nasty numbers, and so we might as well just avoid it and just get to our final answer. So that final answer should be 115.62 degrees. All right, so if you wanted to kind of do all of this all at once, you could go ahead and say that your cosine theta is going to equal, and then we are going to put that dot product all together on top. So you'd have 0 times negative 3 plus 6 times 5. And then the bottom, you would have first the magnitude of m. So you would have the square root of 0 squared plus 6 squared times the magnitude of n, which is negative 3 squared plus 5 squared. So then you've got cosine theta equals, and so that dot product is 30. And then on the bottom, we have the square root of 0 squared plus 6 squared. That is actually going to be just 6. And then for our 3 squared plus 5 squared, that is going to be just the square root of 34. So we could say that that is, let's see, 5 over the square root of 34. And so we will have theta equals the arc cosine of 5 over the square root of 34. And that should give us the angle of 30.96 degrees in the end. All right, so on 15, this is a linear combination. So I'm going to put it into component form really quick. So we're going to have A equals 6, 7. B equals 9, negative 6. So we are going to go ahead and find that dot product. So we'll have cosine theta equals, and we will have 6 times 9 plus 7 times negative 6. And then we will have our magnitudes. So 6 squared plus 7 squared times 9 squared times negative 6 squared. And so that dot product gets us to 12. And then we have the square root of, let's see, 85 for the magnitude of A, and then the square root of 117 for B. So cosine theta is going to be, 12 over the square root of 9,945. And I would go ahead and just move that to theta equals the arc cosine of 12 over that lovely radical. See, it's not letting me write it. Here we go, which should give us 83.09 degrees. And then for 16, P in component form is 1, 2. Q is -3, -6. And then we'll have cosine theta equals 1, -3 plus 2, -6. The square root of 1 squared plus 2 squared times the square root of -3 squared plus -6 squared. And so cosine theta is going to equal, on top you should get -15. And then on the bottom you should have the square root of 5 first. And then the square root of, let's see, 9 plus 36, that's going to be the square root of 45. So you will have -15 over the square root of 225, which will be -15 over 15. So cosine theta equals -1. And so that means that theta is 180 degrees.